Multiplication properties of exponents. So our next unit is all over the properties of exponents. So let's begin by looking at x to the fourth. In x to the fourth, x is what we call the base, and 4 is what we call the exponent. An exponent simply tells us the power that we are raising the base to. So let's look at 2 squared times 2 to the third. We are multiplying like bases. So here both of my bases are 2, so I can multiply those together. Remember that this 2 tells me how many of this base I have. So if I have a 2 here, that tells me that I have 2 times 2. That's being multiplied to 3 2's. And so if I combine all of that back together, or if I simplify this, what I really have is a base 2, and then I have 5 of them. So I have 2 raised to the 5th power. Now, since this is a number, since our base is a number, we can simplify that even further. So in our calculator, you can type in 2 raised to the 5th power, push enter, and you get 32. And so this would be your final answer in this case. Now we were able to simplify it further because our base was a number. Let's try the next one. 3 squared times 3 to the fourth. Again, my bases are the same and I'm multiplying them together. So I have 2 3's and I'm multiplying that to 4 3's. And so when I simplify this, my base is 3, and I have 1, 2, 3, 4, 5, 6 of them. So I have 3 to the 6th power. Again, since my base is a number and my exponent is a number, I can type that in my calculator. So 3 raised to the 6th power, 729. Keep in mind that if you were to type this in from the very beginning, you would also get 729. So let's check that. 3 squared times 3 raised to the 4th power is also 729. So whatever you end up with should match with what you started with. All right, let's look at x to the 5th times x squared. So remember, this tells us how many of these we have. So we have 5 x's. 1, 2, 3, 4, 5. We are multiplying that to x to the 2nd power. So we have 2 more. So now we want to simplify it, so we keep the base x and we add up how many we have. 1, 2, 3, 4, 5, 6, 7. So we get x to the 7th power. This will not simplify any further because our base is a variable. Let's try a to the 5th times a to the 7th. We have 5 a's, 1, 2, 3, 4, 5. We're multiplying that to 7 a's. 1, 2, 3, 4, 5, 6, 7. Okay, and so when we simplify this, we keep our base a and we add up how many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This cannot be simplified any further since our base is a variable. Now let's move on to a more challenging one. These are the ones like what you will see. Okay, so these have multiple bases. Notice we don't just have like bases that we're multiplying. But what we do have is a monomial times a monomial. And within those monomials, we have like bases. So for example, we have numerical values here, and we know how to multiply 3 times 2. We know that 3 times 2 is 6. We have a base x here, and we have a base x here. And so what we know is that this tells us that we have 2 x's. And if I multiply that to what I have over here, then I'm going to add 3 more x's. Okay, and then in addition to that, we have a y. So I need to multiply that as well. Okay, and now simplify it. I have a 6. I have 1, 2, 3, 4, 5 x's, so I keep the x to the 5th power, and then y. And so this would be my final answer. So you expand it all out, and then you simplify it back down. Okay, now let's go back up here to the very beginning. Notice that whenever I was multiplying like bases, the exponent ended up being the sum of 2 plus 3. If I add 2 plus 3, I get 5. Okay, let's look at the next one. The exponent ended up being the sum of 2 plus 4. 2 plus 4 is 6. Look at the next one. The sum ended up being 5 plus 2, which is 7. 5 plus 7 is 12. Look down here. 2 times 3 gives me the 6. 2 plus 3 gave me this 5. And this is y, and so we have y there. So notice that each time that we multiplied like bases, we added the exponents. So when you multiply like bases, you add the exponents. This concludes your notes over the multiplying properties of exponents.